In this video, we are going to see how to find locus of a complex number. Already you know what is locus. In coordinate geometry you would have studied. It is a path traced by a point under some geometrical condition. So same thing here also. Instead of taking a point, we take a point in Argand diagram. That is, we take z is equal to x plus iy. So here the conditions will be modulus, in argument, or real part, or imaginary part, some condition they give. Okay, so before doing the sum, let us see some of the results what you need. You know how to find modulus of a complex number. Suppose z is a complex number, a plus ib. Then modulus of the complex number is root of a square plus b square, root of a square plus b square. And argument of this complex number is, argument of z is tan inverse b by a. And what is the real part of z? Real part of z is a and imaginary part of z is b. So z is a complex number, a plus ib, or you can take x plus iy. Then modulus z is root of a square plus b square. Argument of z is tan inverse b by a. Real part of z is a, imaginary part of z is b. Then how to find a plus ib into a minus ib? You can use the identity a plus b into a minus b. It is a square minus b square. So here you are getting a square minus ib the whole square. If you expand it, so a square minus I square is minus 1. So that minus into minus 1 is plus, then b square. So remember this, a plus ib into a minus ib. A plus ib into a minus ib, it is a square plus b square. A plus ib into a minus ib, the answer is a square plus b square. Then how to multiply two complex numbers? A plus ib is a complex number. C plus id is a complex number. If you want to multiply the two complex numbers, you know here two terms, here two terms. So when you expand, you will be getting four terms. So two terms will be real. That is a term independent of x. For that you multiply first and first, second and second. First and first, a into c, it is ac. Second into second, here I, here also we have I, but when you multiply I into I square, it is minus 1. So I into I square minus bd. So that is a real part. First into first, second into second. For imaginary part, plus I into middle to the last two. Multiply these two, you will get I. Take that I outside, bc. Now first and last, I into CD, I already taken out, so plus CD. So like this you can multiply two complex numbers, a plus ib into c plus id. You can group real part and imaginary part. In a single step you can do like this. For real part, multiply first and first, second and second. First and first, AC, second and second, I into I square minus 1, so minus BD, AC minus BD. Imaginary part plus it, plus I into the middle two, the mean position into extreme position. Multiply these two. I already taken out, so BC plus AD. So these are the results you need to do sums in locus. First, Z is a complex number a plus ib. The real part is a, imaginary part is b. Modulus of a complex number is root of a square plus b square. Argument of the complex number is tan inverse b by a. Then a plus ib into a minus ib, it is a square plus b square. Then how to multiply two complex numbers? Multiply the real part, multiply the imaginary part. You will get the real part here. That is first and first, second and second, plus I into middle to the last two. So with this idea, we are going to see a few sums in locus. I am going to teach three sums. One is in modulus, then another one in real part or imaginary part, and last we will see a sum in argument. Let us see one by one. The first sum I have taken is modulus z minus 4. Modulus z minus 4 is 16. Modulus z minus 4 is equal to 16. Any sum in locus, first you put z equal to x plus iy. Z equal to x plus iy. Substitute here modulus. For z you write x plus iy minus 4 equal to 16. Now write this in standard form. Real part x minus 4 plus iy equal to 16. You know it is in a plus ib form. You know how to take modulus. Root of a square plus b square. A square means it is x minus 4 the whole square plus b square, it is y square. Don't square this I. A plus ib, modulus is root of a square plus b square equal to 16. To avoid the root squaring, when you square the root cancel, x minus 4 the whole square plus y square is equal to 256. 16 square is 256. A minus b the whole square, if you expand it, a square minus 2ab 8x plus b square 16 plus y square, bring this 256 to the left side, minus 256 equal to 0, and the final answer is arrange in order x square plus y square minus 8x. Simplify these two, you will get minus 240 is equal to 0. This is locus of z, and here the condition is modulus z minus 4 is equal to 60. Now let us see another sum. Here the condition is imaginary part equal to 0. Imaginary part of some complex number. So whatever it is. So here the method is you reduce it into standard form. What is the standard form? A plus ib. Then take the imaginary part, equate with 0. Instead of imaginary part, they can give real part. Instead of 0, they can change the number. Whatever it is, same method only. Here the method is you take this part, put z equal to x plus iy, arrange it into standard form. So let us see how to do this. Put z equal to x plus iy. Put z equal to x plus iy. We take this part, that is 2z plus 1 by iz plus 1. For z you write x plus iy. So 2 into, for z you write x plus iy plus 1 by I into z. Z is again x plus iy plus 1. Expand the numerator, 2x plus I into 2y plus 1 by ix plus I into I square, it is minus 1. So we write minus y plus 1. Now the numerator write in a plus ib form. Denominator also write in a plus ib form. See the real part 2x plus 1. So 2x plus 1 plus I into 2y. Denominator, the real part is 1 minus y. Then plus ix. So now we multiply numerator and denominator by its conjugate. That is, instead of plus you put minus. So you multiply by 1 minus y minus ix. Same thing in the denominator also, 1 minus y minus ix. See the denominator. Denominator is of the form a plus ib into a minus ib. A plus ib into a minus ib is a square plus b square. So a square 1 minus y the whole square plus b square, it is x square. Numerator, two complex numbers, a plus ib, c plus id type. So for the real part, first and first, multiply these two, first and first, 2x plus 1 into 1 minus y, first and first. Second and second, plus into minus is minus, but I into I square, that is another minus. So plus 2y into x, or you say 2xy. That is the real part. Now for imaginary part, plus I into. For imaginary part, you know, you multiply these two, middle two and the last two. So I into middle two, these two you multiply, right? So I into 2y into 1 minus y. 2y into 1 minus y. Then first and last, minus x into, I already taken out. So minus x into 2x plus 1. So now you split into two. Suppose a plus b by c. You can write it as a by c plus b by c. So same way, we split into two. This by this plus this by this. So a plus ib form you write. So first this by this. 2x plus 1. 2x plus 1 into 1 minus y plus 2xy divided by denominator 1 minus y the whole square plus x square. That is the real part. Plus I into 2y into 1 minus y, 2y into 1 minus y minus x into 2x plus 1 divided by the same denominator 1 minus y the whole square plus x square. 1 minus y the whole square plus x square. Just we split into two. This by this plus this by this. Now this is of the form a plus ib form. This is of the form a plus ib. Now read the question. Up to this it is common. The question is whether imaginary part or real part or even argument also you can do in this way. Now what is given in this question? Imaginary part is 0. It is given in the question imaginary part of 2z plus 1 by iz plus 1 equal to 0. Imaginary part means b. b is equal to 0. A is the real part, b is the imaginary part. So this is the imaginary part. So take this part. 2y into 1 minus y minus x into 2x plus 1 divided by 1 minus y the whole square plus x square is equal to 0. Now we cross multiply. Since it is 0, it's very simple. 0 in anything it is what? 0. Only just expand the numerator. 2y into 1 it is 2y minus 2y square minus 2x square minus x equal to 0 in anything it is 0. If it is minus 2, you write minus 2 into this, right? Now you arrange in order. Also first term we want positive. So change the sign throughout. So this becomes 2x square plus 2y square plus x minus 2y equal to 0. So this is locus of this z under the condition imaginary part equal to 0. Let us see one more question. In this question, argument of this complex number is equal to pi by 4. Argument means the form argument is tan inverse b by. So same method for z, you take this part, put z equal to x plus iy, reduce it into standard form, then apply the condition, you will get the answer. So put z equal to x plus iy. You take this part, z minus I by z plus 2. For z you put x plus iy. So x plus iy minus I divided by x plus iy plus 2. Numerator arrange in order. Real part only one term x. Imaginary part two terms. Take I outside. You will get y minus 1. Denominator real part two terms. The term independent of I. X plus 2 plus iy. Multiply numerator and denominator by its conjugate. Instead of plus you put minus. So x plus 2 minus iy by the same thing, x plus 2 minus iy. Now the next step, that's a very important step. Denominator, if you expand a plus ib into a minus ib, a square plus b square, a square, it is x plus 2 the whole square plus b square, it is y square. Numerator you do it, expand it. First and first, second and second. First and first, x into x plus 2. Second and second, plus into minus is minus, but I into I square, that is also minus. We are going to multiply these two. Plus into minus, minus, I into I square minus, so it is plus. Y into y minus 1. Y into y minus 1. That is the real part. Plus now for imaginary part, you group these two, middle two and the last two. Plus I into, what's the remaining? Multiply these two. Y minus 1 into x plus 2, or you say x plus 2 into y minus 1. X plus 2 into y minus 1. Now last two, first and last, I already taken out, so minus y into x. So minus yx, or you say xy. Minus I already taken out, x into y. Okay, xy. Now we split into two, this by this plus this by this. So what you are getting? So at the same time I am multiplying this, x into x, x square plus 2x plus y square minus y divided by the denominator is x plus 2 the whole square plus y square plus I into, here also I multiply xy minus x plus 2y minus 2. Then here you have a minus xy divided by the same denominator x plus 2 the whole square plus y square. Now this is of the form a plus ib. This is of the form a plus ib. This is a and this is b. Also here you can cancel this plus xy and minus xy. So now see what is the condition given here. Argument is pi by 4. So it is given in the question. It is given argument of z minus I by z plus 2 equal to pi by 4. Argument formula tan inverse b by a. Tan inverse b by a is equal to pi by 4, or b by a is equal to tan pi by 4. Tan inverse, when you take there, b by a is equal to tan pi by 4. Tan pi by 4 is 1. Tan 45 is 1. So cross multiply, b is equal to a. b is equal to a into 1. It is a. Substitute the values. This is a and this is b. So b equal to, b means the coefficient of I. It is minus x plus 2y minus 2 divided by x plus 2 the whole square, x plus 2 the whole square plus y square equal to a. A is the real part. X square plus y square plus 2x minus y. X square plus y square. X square plus y square plus 2x minus y by x square plus y square plus 2x minus by the denominator x plus 2 the whole square plus y square. Same thing. X plus 2 the whole square plus y square. Both the denominators are same, right? You can cancel the denominators. Now take every term to the right side. Already here we have x square plus y square plus 2x minus y. Take these terms to the right side. Minus x, if you take there, it become plus x. 2y, it become minus 2y. Minus 2 become plus 2 equal to 0. Simplify. X square plus y square. 2x plus x, it is 3x. Minus y is minus 3y plus 2 equal to 0. So this is locus of z under the condition argument is equal to pi by 4. Here the given argument is pi by 4. If the angle change, only thing here you have to make some change. Suppose if they say pi by 6, 30 degree, tan pi by 6, 1 by root 3. That values you substitute, then you cross multiply, and all the methods are same.